interfacing DHT11 sensor with ESP32. So first, what is DHT11? So the DHT11 and DHT22 sensor is a low-pass digital temperature and humidity sensor. It is commonly used to measure the temperature and relative humidity of the surrounding environment. The sensor consists of a thermostat to measure temperature and a capacitive humidity sensor to measure relative humidity. So the DHT11 and DHT22 sensor has a simple digital interface and it is easy to use with microcontrollers and single board computers like Arduino, Raspberry Pi and others. It communicates over a one-way serial protocol and provides accurate and reliable measurements. The sensor is widely used in various applications such as indoor climate control, weather stations and greenhouse automation. So now let's see the difference between DHT11 and DHT22 sensor. So first, coming to resolution, it is about humidity is 1% and temperature is about 1 degree Celsius. And in DHT22, it is about humidity is 0.1% and temperature is about 0.1 degree Celsius. So the temperature range is about 0 to 50 degrees Celsius in 11 and minus 40 to 80 degrees Celsius in DHT22. And humidity ranges 20 to 90% here and here 0 to 100%. And in DHT11, the operating voltage is only 3 to 5.5 volt DC. And coming to 22, it is 3 to 6 volt DC. And current supply is about 0.5 to 2.5 milliampere. But in 22, it is 1 to 1.5 milliampere. So the sampling period in DHT11 is 1 second and here is 2 seconds. So this is about the difference between the DHT11 and 22 sensor. So now let's write the code. Okay. First we have to install library called DHT11. So like open your Arduino IDE and go to the sketch, include library, manage libraries. Here search DHT. Here you can find by Adafruit. I already installed this. If you have not installed this, then just click install. Okay. So again, and another library also we had to install, which is Adafruit Unified Sensor. So search Adafruit Unified Sensor. So this one, install this too, and now we can write the code freely. Okay, now let's write the code. First we have to include the DHT sensors library. So include DHT.h, and now let's define the DHT pin is 4. Okay. Now define DHT type. So here we are using DHT11, right? So DHT11. If you are using 22 in the sense, you can refer here DHT22. So now I am going to create an object for DHT object called DHT. So DHT object, we can give DHT. Inside I am going to mention the DHT pin and its type. Yeah. So now inside void setup, I'm going to use serial dot begin of 9600. Now I'm going to start DHT. So DHT is begin. Yeah. Now inside while loop, because I'm going to make a delay. So as I told earlier, the maximum sampling period of DHT11 is 1 second, right? So I am going to start with the delay of 1 second. So now I am going to read the humidity and temperature. I am going to store it in a variable called float. First let's read the humidity value. So DHT dot read humidity and then float like T DHT dot temperature. Now float of F. This is for if you want to get the temperature in Fahrenheit degrees Celsius, then you need to pass the argument inside for like DHT dot read temperature. So inside you have to give true. Now let's print the value. Serial print of, let's give F and again inside humidity. Yeah. Serial dot print. Here I am going to print that humidity value. So serial print F inside percentage temperature space. Okay. Now serial print, I'm going to print that T. Serial print of F and inside going to give degree Celsius. So degree Celsius Now serial dot print, I'm going to print that F. So now serial print ln F inside the Fahrenheit. Yeah, let me verify it first. Okay. Okay. Now let's move to the hardware part. So this is our DHT11 sensor. Let me connect it first. So first I'm going to give power. So VCC we can give to 5 volt. And then data pin. We have mentioned data pin as 4th pin, right? So 4 and ground. Okay. So now let's upload the code. Open your serial monitor. So here you can see the out. So humidity is 81% and temperature is 30.20 degrees Celsius, and this is in Fahrenheit 86.36. If you blow your sensor in the cells, you can see the difference. So this is our output. That's it. ESP32 DHT11 interfacing with ThingSpeak web server. So we are going to interface DHT11 sensor with ESP32 and going to upload the data in ThingSpeak web server. So we have already see how to interface DHT11 sensor with ESP32 in sensor interface session, right? So here we are just going to upload the data in the web server. So first, why ThingSpeak web service? So it is an open data platform for the Internet of Things. It is a MathWorks web service that allows us to send census reading data to the cloud. We can also visualize and act on the data, which means we can calculate the data sent to ThingSpeak by the devices. Data can be stored in both private and public channels, and then it is commonly used for Internet of Things prototyping and proof of concept systems requiring analytics. So why we have to upload data in web server? The IoT is the interconnection of physical objects or devices with sensors and software accessing capabilities to communicate data or information over the internet. To build an IoT network, we need an interface medium that can fetch, control and communicate data between sender and receiver electronic devices or servers. Espresso Systems created the ESP32 Wi-Fi chip series. The module is equipped with 32-bit 10 silica microcontroller, 2.4 GHz Wi-Fi connectivity, antenna, memory and power management modules and much more. All of these built-in features of this ESP32 module make it ideal for IoT applications. So first, let's log into the ThingSpeak web server. So here just type thingspeak.com. I have already have an account in ThingSpeak server. So if you guys don't have account, this is just use your mail ID and log into the account. So here we have to click channels and just click new channel. Give name like DHT11. So I'm going to use this field as humidity and I'm going to use another field called temperature. Scroll down and save this channel. So here it will show the channel ID, author, access is private. You can set to public view also. So we are just going to make it private. So it will create a like humidity and temperature chart. This is API keys. We have to copy this and paste it in our code. Let's see. So now let's move to the software part. So here I am going to write the code. First I am going to give style guard. So the style guards are used at the beginning of the program to declare some functions to be of C linkage instead of C++. Basically to allow C++ code to interface with C code. For that I am going to give if def underscore C++. Now I am going to extern C. Now open the braces. Inside I am going to give endif. Now I am going to give unsigned integer data variable called temperature sense read. So then if def of C++ again. So then I'm going to give endif again unsigned integer temperature sense read. Okay. So now we are going to adding the required header files. So in this code we are using 3 libraries. First one is include Wi-Fi.h library, and then include DHT.h library. So we have already discussed about how to download and add the DHT and these libraries in previous session, right? So now I am going to include ThingSpeak library. I will provide you the zip file in the description. Just go and download it. ThingSpeak.h. So now we have to enter the network credentials. For that I am going to create character SSID. This is my Wi-Fi name. Again character pass phrase. So now to access the created web server, we also need to assign a port. So Wi-Fi server. Inside I am going to give 80. So 80 is used for local web server. And then Wi-Fi client is created to connect the ThingSpeak. Wi-Fi client. So now I am going to add the channel number and I am going to add API key. So unsigned long my channel number. I'm going to create one channel. If you create a multiple channel in the sense, you can give accordingly. So now here I'm going to only add one channel. So now unsigned, I just can give constant character my API key. Write API key. We are going to write the API key. So here we have to enter our API key. So just go to your ThingSpeak web server and copy this and paste it in your code like this. So now I am going to declare the global declaration of timer variables. Unsigned long last time 0, let's give 0. Unsigned long timer delay, let's give 1000. So now I am going to define DHT pin and its type. So define DHT pin is 4. Define DHT type DHT11. Now we are creating a object called DHT. Instead I am going to pass DHT pin DHT type. So now coming to void setup. First I am going to serial.begin baud rate. So this, and now I am going to print SSID. So serial print. First let us print connecting to, and then I'm going to print SSID. So now I'm going to enabling ESP32's Wi-Fi. So Wi-Fi dot begin. Instead I'm going to pass that SSID and passphrase. So now here I'm going to make a while loop to wait until the ESP32 is not connected with the Wi-Fi network. For that I'm going to make a while loop. Call inside Wi-Fi dot status not equal to connected. So here I'm going to give a delay like 500. So here I'm going to serial print like dot. So now here I'm going to print the Wi-Fi connected and the IP address. Serial print ln. Instead I'm going to just give blank. Serial print ln. Here I'm going to print like Wi-Fi connector. Serial print. Here I'm going to paste my IP address. So IP address serial print ln like Wi-Fi dot local IP. That's it. Now I'm going to begin server. So server dot begin. Now DHT dot begin, and I'm going to begin ThingSpeak. ThingSpeak dot begin. So coming to while loop. Inside first I'm going to give if condition. So millisecond. I'm going to calculate the timer. So lost time greater than timer delay. Inside I'm going to give a delay of 2500, and then now I'm going to read the humidity value, temperature value, and going to store it in a variable. So float h equal to read humidity, not just read humidity, DHT dot read humidity, and then float t equal to DHT dot read temperature. I'm going to store Fahrenheit, so F equal to DHT. For that we just have to pass 2 as an argument to store the Fahrenheit. That's it. So now I'm going to make another if condition. For what? In the sense, if somehow the sensor fails to read or observe the temperature or humidity values, then the respective results will be printed on the serial monitor. For that I'm going to create this one. Is nan. Instead I'm going to give h or going to give T. Sorry, F. So inside serial dot print ln like. Fail to read from DHT sensor. If it doesn't read anything in the sense, it will print like this. So then return. So now I am going to print the values. Serial dot print temperature inside Celsius, then serial print of temperature, serial print ln into degree Celsius, serial print humidity serial print ln humidity value. Yeah. So now I'm going to give ThingSpeak dot set field. I'm going to set the field here. We are using two field, right? So here I'm going to first field is humidity set field, second one is temperature. So yeah. So then I'm going to make variable called int x ThingSpeak dot write fields. Inside I'm going to pass my channel number, my write API key. So this is for the write field function is used to write the data to the ThingSpeak server. This function is used to the channel number and API key as an argument. Then I'm going to make another if condition. For what in the sense? X equal to 200. Why? Because it returned the code 200 if the sensor readings are successfully published to ThingSpeak server and print the respective results on the serial monitor. So for that I'm going to give, first I'm going to print serial print ln inside like channel update successful. Else serial print ln like problem updating channel and http error code plus string of that x. So here to give last time equal to millisecond. Yeah, that's it. So first let me check it first. I make sure that you are connecting the right board and port. Yeah, so verify it. Okay, now our code is error free. So now coming to the hardware part, in the sense the same connection. So the DHT sensors VCC pin, ground pin and data pin is connected to the VCC pin of ESP32, ground pin of ESP32 and the data pin is connected to 4th GPIO pin. So now let's upload the code. So now open your serial monitor. So here a temperature and humidity sprint. So channel updated successful. If you are opening your ThingSpeak, in the sense, here you can see the output. So this is our output. Let us wait for a few seconds. It will change according to the values. So like this, 79, 79, 79. Here 32.8 is our temperature. So just blow your DHT sensor, you will see the variations in the output. So that's it.